Everyone, welcome to S44 is tackling the biggest challenges in the EV charging webinar. This is the third webinar in our webinar series. My name is Jason Cardosi. I'm the head of sales for S44. Appreciate everyone taking the time to be with us today. We have a webinar planned that is going to cover two major topics focused around roaming and payment solutions that S44 is bringing to market. We have a panel of speakers, including myself, Thana Paris, our Director of Open Source, and Christian Weissman, a Senior Software Engineer. Quick background on S44, quick background on me. S44 is a custom software development company that has been in and around eMobility and EV charging for over a decade now. We've been building proprietary solutions, including an open source CSMS called Citrine OS for the past year or so. I've been in mobility, transportation, and working with OEMs, building software solutions, both in SaaS and custom, for about 17 years. And today we are going to hit the following topics on today's webinar. First, we're going to talk about EV roaming, what it is, and some of the challenges around it, dig into payment and some of the payment solutions that we've brought to market with our CSMS offering. Talk a little bit about Citrine OS, which is the open source CSMS that we build a majority of our client CSMSs on top of. And I'll talk a little bit about how we do that and what the go-to-market looks like for that. And then we're going to turn it back over to all of you and open it up to Q&A. For a little housekeeping for the webinar, we have the chat, I believe, is disabled for this webinar, but we do have the Q&A functionality turned on. So at any given time, please put your questions into the chat, and we will monitor that throughout the presentation and address those questions during the Q&A session towards the end of the webinar. With that, let's kick things off. I will introduce Christian Weissman, who's our lead engineer, been working on mostly EMSP work for the last little bit. He's a contributor to the OCPI 3.0 protocol, and S44 has been part of the EV Roaming Foundation for some time. I'll let Christian jump us off talking about EV roaming and OCPI.
All right. Hello, I'm Christian. So if you travel across the country, then often what you'll find is different regional operators and competitors of charging networks. And from that, you get a fragmented charging space. What that results in is a complex user experience where you don't know what you're getting, where you think you found a station, but you don't know what it looks like or if it works. You don't know what you're going to be paying. And you have to consider again, does my app work? Does my app not work, etc. And that's basically where roaming comes in. So if you travel into a different country and you turn on your phone, then usually it just works, right? It connects maybe to a different provider, but all in all, you surf the internet, you call someone, and it works. Under the hood and between the cell phone operators, there must be something going on. And in EV roaming, you can consider the same. So if networks have some agreements between each other, then ideally you just pull up and you use your normal app and you're able to charge wherever. The complexities of billing and payment between the operators is hidden from you. And one approach for this, if you go to the next one, Jason, is the Open Charge Point Interface, or OCPI, maintained by the EV Roaming Foundation. It's an open protocol that facilitates the communication between basically two layers of the players here. So there's the charge point operator, the one that maintains the physical stations in the ground. And then there's the EMSP, the eMobility service provider. So I, as a driver in my car, might plug in, I need to go to spot X. And then my dashboard app probably has an integration with an MSP and can pull in the data along the road and where I should charge. Ideally, I can even charge straight out of there, but maybe that's a topic for another time. So OCPI facilitates the communication between the CPO and the MSP. And the nice thing about it is that they're a peer-to-peer model. So the network and the mobility service provider can haggle out their own business agreements. They can discuss how much to pay between each other per kilowatt or whatever special deals they want. And that's maybe a direct advantage against other roaming setups where there's a hub that forces you to use certain setups and maybe takes a cut. The ideal thing with OCPI is you can also have a hub model, such as an API that operates a hub that maybe doesn't even take a cut. Further, in North America, NEVI has been rolled out, and that's the infrastructure program of the US government to further EV adoption. And it even mandates OCPI implementation so that there's a that we're reducing the fragmentation of the networks. So on the long trip, you'll find charging most easily. Now taking a look at some real world setup. So let's say I am the person in the green car and I pull up to a charger in the ground. Ideally, it's OCPP 201 and it communicates with its CSMS. Then the CSMS ideally implemented OCPI 2.21 and can communicate with my MSP. So I pull up and I say, all right, start the charge, and the complexity around billing and everything else is hidden from me as a user. So what OCPI does is basically it enhances the real-time operation. I can communicate or interact with my charger in front of me, but it's part of a wider network. What we've seen a bit now in the field is some compatibility issues around the new OCPP 201 three-tier model and some MSP pricing setups. But we're quite excited for OCPI 3.0. And I think there's lots of great things to come there. My personal favorite is the party-issued object replication. I think it's a great setup to improve and push out more close to real-time updates and not necessarily relying on pull models. And then if you go to the next one, Jason. So the idea behind roaming and why we like OCPI is that it allows me not to think where I should charge. So it should be, or roaming basically improves our charging experience by bridging the gap between the different networks. And it creates a seamless user experience from a single point of contact with the user, and it hides some complexity. Thinking further down the road, it also creates a more robust EV ecosystem by reducing like range anxiety and other things that might not be ideal for EV drivers. And it promotes a healthy competition where if you have a popular spot and you have multiple networks, then and you can charge by any of them, then the one that has the real value add is the one as a consumer that you're going to pick. So because of these points, we've decided to also implement OCPI 2.21 into Citrino S and allow roaming from our CSMS that Jason has mentioned. With that said, and because I'm excited for OCPI 3.0, we're also planning to work on implementing the 3.0 spec towards end of the year. And with that, I'll hand it over to Thana around payment.
Hi all, I'm Thana. I'm the Director of Open Source Program at S44. I've been leading the development of the Citrino S Charging Station Management System project since its kickoff initiation last year. And before that, I worked helping to develop one of the largest CPOs in North America. And today I'm going to be talking about payment, and specifically how payment in EV charging presents some new challenges. One might think that coming from gas stations, that payment is a solved problem. After all, it's been happening there for some time, and it's a seamless user experience today. But EV charging presents both some unique opportunities for an improved experience, as well as some unique challenges. So on the plus side, when you're charging your electric vehicle, when you plug in, it's not just electricity that's coming over the wire, it's information. And this provides an opportunity for a more seamless user experience because the car can communicate with the charging station can then communicate with the cloud, and this opens up payment opportunities such as plug and charge, where the user can have payment and a user account in an MSP, and that will take care of payment as soon as they plug in their vehicle, no further actions necessary. Since chargers produce so much data, they always need to be connected to the cloud. And that also opens up some pricing opportunities, and it's what underpins plug and charge. In the negative side, EV chargers are usually not in areas where staff have easy access or visibility to them. Unlike a gas station, EV chargers are commonly put in the far-flung reaches of a parking lot or in an area that isn't trafficked by any employee who could help people with those chargers. On top of that, the chargers themselves produce a lot of heat, and the constant heat leads to much more frequent hardware failures that then, due to the isolation of the chargers, doesn't always get surfaced in a timely manner. This is particularly apparent with credit card terminals, as the operators of the chargers don't always have a lot of insight into the operation of those terminals. And it's been a frequent issue with DC fast charging that EV drivers will pull up to a charging station and the terminal will be broken, and they will have had no idea about that beforehand. So as I mentioned, the chargers produce a lot of data, a lot of information, and as a result, they maintain a connection with the cloud. That connection is mediated by the Open Charge Point protocol. Communication over OCPP allows for a number of different ways to authorize the user that then can upstream draw authentication from an MSP via roaming, just like Christian described. This means that for EV drivers who have an account with an MSP, whether that be an app on the dashboard of their car or some mobile app that they have that they use to charge their vehicle, they can have a seamless experience when it comes to payment. However, this still leaves open the question of anonymous payment. If users don't want to have to create an account in an app, they don't want to have to use a mobile app or dashboard app in order to facilitate the charging of their vehicle, They don't have other options for anonymous payment. Often, the only option is the credit card terminal. So we've proposed a different option, which is scan and charge. And this has been seen already implemented in some areas with static QR codes. But OCPP allows for the charging station management system to push images down to the charger to be displayed on the user interface. This means that a QR code encoding a payment link can be pushed down to a charger after an EV driver has arrived at the charging station. The EV driver could then scan this QR code from the user interface of the charger and with their phone, and then that would take them to a payment portal where they can enter in payment information. There, a payment processor would authenticate the payment information, and most payment processors allow for a redirect link after the user has provided payment and that payment has been authorized. This means that after a user has arrived at the charging station, scanned the QR code that was generated for their transaction, entered in their payment, then they can be sent to a web portal that can give them insight into the state of charge, meaning that as electricity starts flowing, they'll be able to see how much they've charged, what percentage the state of charge is for their vehicle, and they'll have this insight without needing to create an account on a mobile app. And this is all a distinct advantage over a credit card terminal, because by using OCPP communication, you reduce the points of failure. OCPP communication gives you more insight into the behavior of the charger, and you'll know immediately if there's an issue. So you can surface issues with payment much more quickly than if it were a hardware module, such as a payment terminal, a credit card terminal. So this is an actual real-world example of how you could do this with OCPP 201 and Stripe as a payment processor. You can use the display messages in OCPP 201. There's a set display message and a clear display message, so that you could generate the payment link via Stripe's API, convert it to a QR code, send that QR code to the charger via a set display message, and then the user, the EV driver, could scan that QR code. They'll be sent to a Stripe payment portal. They put in credit card information or use something like Google Pay or Apple Pay. And then once they've been authenticated, they'll be redirected to a web portal that shows them the current state of charge, which is, as I mentioned, a major advantage over something like a credit card terminal, where you're not going to be able to remotely monitor the charge. You'll have to be at the charger in order to see what the state of charge is. So this overall flow under the hood involves a trigger after the payment processor has authenticated payment. A remote start, an OCPP command to authorize a charge, is sent down to the charger, which initiates the electricity flow. Since all of the messages that the charger receives are part of the protocol, you could set up this same system using a different payment processor. It doesn't have to be Stripe. You could even use a deep link to a pre-existing mobile app if you want to try and introduce the user to your ecosystem. Ideally, they would still be able to check out anonymously, but this would try and draw them into your ecosystem with the user experience. There are some challenges still for scan and charge being implemented in the field. So OCPP 201 is still in the early stages of wider adoption. We've talked in previous webinars about the sort of state of adoption and why it's important that 201 continue to be adopted. Many major charging stations don't yet support the ability to update the UI using the messages that come out of the box of the protocol the ones that I mentioned, the display message related messages. Currently, the most common way to update the UI for a charger is through a proprietary vendor backchannel, which for a charging network that might have multiple different types of hardware in its network is very much not optimal, because it means you can't have centralized logic for doing something like scan and charge, where you can update the UI of any 201 compliant charger, regardless of the vendor that created the charger. So moving forward, as we've said in previous webinars, it's going to be vital for the progress of the industry and the improvement of the user experience to see wider and more complete OCPP 201 adoption. And a note on the QR code generation. I mentioned that there is already in some places the ability to scan QR codes. There was at some points the ability to have a QR code that you would scan that was actually physically on the charger, but this proved to have security concerns, and it's even been made illegal in some countries due to it being easily manipulable. Any sort of static QR code is going to run into this type of security concern, which is why it's vital that the QR codes for scan and charge are dynamically created and unique per transaction. So to sort of sum up what I've said so far about pricing, about payment, EV charging presents some unique opportunities for improving the user experience when it comes to payment. It also presents some unique issues with how payments can work. And with the future of OCPP 201-based control of charging stations, the scan and charge system will provide a reliable, flexible way to have anonymous payment at an EV charger without any compromise of the user experience. So I've mentioned that we've mentioned that we work on the Linux Foundation project, Citrine OS. It's an open source charging station management system that was originally based on the OCPP 201 protocol. It's API based and modular, meaning that it can be headless, it can go behind existing user interfaces or into existing systems, and it's modular, so it's extendable. As part of our most recent 1.3 release, we expanded the protocol stack, as Christian mentioned. We now support OCPI 2.2.1 from the CPO side, meaning that Citrine OS can behave as a charge point operating system for EV roaming. This 1.3 release also introduced the payments module. The payment module was initially contributed by Stackbox, and that sort of showcases how the modularity of Citrine OS allows for the community to create additional value adds and for implementers to customize the OS and add additional features specific to their use cases. S44 also added the scan and charge feature to this payment module as part of the 1.3 release using Stripe. Citrine OS provides, through the OCPP 201 connection to chargers, deep insights into the behavior of those chargers, into their current state. It makes it easy to commission new chargers and new assets, and it's relatively simple to introduce Citrine to a system that may have some legacy support or legacy systems already existing for, say, an OCPP 1.6 network. And to continue describing Citrine OS and S44's approach to implementing it, I'm going to pass it back over to Jason.
Thank you, Thana. Thanks, Christian. So I'm going to talk a little bit about how we actually do it. We spoke about what are the challenges within the market, and what my next part of this presentation is really to discuss how does S44 bring these solutions to light, or how do we actually build them for you or allow you to build them, using some of the technology that we have in the open source today. So really the foundation is the Citrine OS CSMS, which is, as everyone mentioned prior, a OCPI 201 Linux Foundation adopted project. Really what our go-to-market is and what we do, kind of going back to kind of who is S44 and what makes our offering unique is we're a product company of, again, over 12 years. But we have a professional services background, and that background really gives us a unique position to be able to take the open source foundation and then build solutions for our clients based on really what their requirements are. One of the questions that I get asked a lot is, Jason, what's the difference between Citrine OS and S44 CSMS? And I tried to visualize it as much as I possibly could in this slide. Really what we're doing for our clients is working with them to understand what their requirements are, what do they need in a CSMS, and taking what's already existing within our open source foundation and then building that in a way for them to be able to, number one, have a solution that they own, where they have the intellectual property rights long-term under their control. Number two, do that in a way where it's a one-time flat fee. So there's no reoccurring costs or anything with our model. We're more or less building something custom to our customers' needs, deploying it within their ecosystem, tailoring it to exactly what their business calls for today, and then supporting what they need long term, so that the end product isn't the simple open source version of the solution, but an actual solution that is tailored and owned by our end client. And when you start to look at what does that mean to the end user, there's a bunch of different benefits where owning and operating a custom CSMS really brings to light some of the advantages of both technically and operationally. And then I guess if we're going to start right off with cost savings, even on the expenditure side of the house, as to how this makes sense for a lot of our clients. To me, it's really the conundrum of, do I buy a CSMS or buy a SaaS product, or do I build my own CSMS? Right, someone who's sort of in that no man's land. That's really where we come into play to help support some of our clients. So on the cost saving piece, again, we normally come in with a fixed approach to be able to build something and deploy it for our clients, all in a one-time fee approach. And with Citrine OS being API first and also being completely modular, it allows us to not only build a custom solution to the APIs that the client needs from an operational standpoint, but also connect into their existing ecosystem and to connect into their existing network for any custom needs or data pipelines, or really anything that they need to have from a data standpoint that has the ability to hit one of the APIs. We hear a lot that CPOs especially need to have that level of control. So not only when they own a solution do they have higher control levels over how to actually run their business, but again, our model is to fork the code off of an Apache 2.0 license. That is what Citrine OS runs off of. And we allow our clients to be able to essentially retain the intellectual property rights of both the core CSMS and then any additional modules or any additional features that they choose to build long term on top of the core functionality. And my favorite is that we do it a lot faster because we already have the core open source there to use. So if you were to compare that to a full CSMS build from scratch, it's somewhere between 80 and 90% faster. But again, because we have the OCPP 2.01 reference implementation of Citrine OS, we have the ability to build any tailored solution on top of that open source platform. The OCPP 201 benefit really is that we open up the ability to choose any 201 hardware, allowing any network to be able to purchase and procure hardware of their choice. And the scalability piece of the solution is also very important because we see a lot of organizations that are looking for just a core implementation of a CSMS, but they have long-term aspirations to either build custom features or adopt custom features similar to the payment and the roaming implementations that Don and Christian spoke about longer term, right? So we have the ability to, again, use the open source as the foundation, and then based on the project, based on the customer, based on what challenges and changes that they're going to see in their business, put together plans to be able to build out a solution that matches what the business calls for. And then outside of our team being there to support our customers the whole way, because Citrine OS is simply so flexible, API-based and modular, again, depending on who the customer is, what their business calls for, and how basic or how advanced the feature sets need to be. S44 has the ability to really work in tandem with any organization to actually build something that's going to solve these challenges that we are seeing in the EV charging market. So with that, I think we have officially hit the Q&A session of the webinar. We're just about on time. Again, everyone, thank you for joining. And let's see what we got in the Q&A. And if anyone has any questions too, now's a great time to pop them into the Q&A chat.
I see one question. Does plug and charge work with roaming? Do you want to cover that, Christian, or shall I?
You can go for it.
So in plug and charge, there's actually the same roles roughly as there are in roaming. Plug and charge defines a CSO, a charge station operator, and an MO, or a mobility operator. And those roles are basically equivalent to the CPO and MSP roles in OCPI for roaming. So yes, plug and charge not only works for roaming, but was actually designed around roaming as a concept. In plug and charge, it uses a slightly different method than other methods of authorization, but it fits into an OCPI stack perfectly. So it does. They are compatible.
I had one question that came in prior to the webinar that I'll pose to either Thon or Christian, if that's okay. If I deploy Citrine OS or have S44 do it for me, how plug and play is the Stripe integration?
It's fairly simple to set up. It does require a Stripe account and some of the secrets from that Stripe account to be put into the database in order for it to operate. But it's pretty simple to add to your Citrine OS instance. because it hooks into the message broker like the rest of the modules do. So there's no special configuration it needs other than what information you use for your message broker, and then some Stripe account secrets that would be put into the database. And it has some documentation to make that even clearer.
All right, I know there's more questions out there. Everybody use that chat Q&A, please. What is the feature set for OCPI, and is it fully implemented?
Christian?
Sure. So we released 0.2, and so most features are there. I think there's a few nitpicks around reservation, but the important things are basically location and tariffs, and so we've implemented those. They hook into the Citrine core, and basically we avoided data duplication inside the system, and we've been working on testing it. Yeah.
Yep. We've been testing specifically, we've had the opportunity to test with Anapi and their OCPI 221 implementation. And we're going to have our first full major release of the OCPI modules in our next release. So as Christian mentioned, right now, the release version is 0.2. 1.0 is going to have everything. Really, like Christian said, the only bit that isn't there yet is reservations, but that's going to be added, and that release will actually be happening in about 2 weeks.
I'll throw one out there. Does Citrine OS support OCPP 1.6 chargers?
So right now, out of the box, Citrine OS does not come with the ability to process 1.6 messages. That is something that is on our roadmap to have a basic 1.6 implementation. We've mentioned in previous webinars a little bit about why we approached it this way. 1.6 implementations are very heterogeneous, which is to say that if you have a charger that works with 1.6 central system, you have a charger that works with 1.6 central system. Every single vendor has a slightly different flavor of 1.6 because of the limitations of the protocol and the gaps that were in it that 201 addressed. That being said, we understand that there's a need to migrate and support legacy chargers. And with that in mind, we are intending to add some 1.6 support to Citrine within the year.
I got this one via email about an hour ago, and it's one of Donna's favorites. What's the status of OCA certification? I'm trying to see if the person who asked it is on the webinar. I'm pretty sure they are.
So OCA certification, the OCA provides a testing tool, the OCA testing tool, or OCTT. We've had the opportunity to use that to validate the core and advanced security use cases. However, in order to get the full certification from the OCA, there's a requirement to have a UI, and then the certification is tied to that UI. We are actually going to be doing a big UI update in about a month to Citrine. And so we're going to be pursuing OCA certification after that update so that the user interface permits the certification process. So soon. We already have the business logic, if you will, confirmed using the testing tool. So part of the battle is already done, and now then the actual logo and certification process will be happening in about a month or two. I see there's some additional questions in the Q&A. One, what is your point of view on the PNC/PKI ecosystem? Are you planning to integrate that to your platform? That's a good question. So the plug-in charge specification, ISO 15118, mandates the presence of a certificate authority because plug-in charge functions off of a public key infrastructure, which is a type of security that requires a trusted third party to validate the encryption of the messages within the protocol. That trusted third party is the certificate authority. And out of the box right now, Citrine aims to support Hubject as the certificate authority because that's the one that's most widely used in North America. So we have the ability to interface with Hubject's API. So that part is already integrated. And in the future, we may integrate additional PKI ecosystems as they see adoption in the space. So I see a question that's similar to what Jason asked. Is Citrine OS out of the box ready for OCPP 201 certification? So in terms of the business logic, the ability to reply to the messages according to the spec, yes, and we've validated that with the OCA's testing tool. However, the full certification process requires a UI. So we are going to be, as I said, making some updates to our UI, and then after that, we'll be pursuing the certification. And if you were using, say, Citrine OS to augment an existing tech stack that already has a UI, you would be able to pursue certification as soon as you have Citrine started up. So if you already possessed a UI, you could pursue certification for your backend pretty much the moment Citrine is running on your system.
Cool. Good questions. Keep them coming, everybody. There's one that just came in.
Donna, you're muted.
Yeah, sorry.
You see it, Donna?
Yeah, I see it. I see it. How can you help OCPP 1.6 based platforms achieve OCPP 201 capabilities? So there's a few ways that Citrine can help you bootstrap to 201. From the charging station management system side, so from the cloud side, since Citrine is API based and modular, we've tried as much as possible during its design by using API based and modular to make it so that you could pretty much just drop it into an existing cloud system that manages connections to chargers. So you don't, if you wanted to, for example, put Citrine behind an existing system that already receives the messages over the WebSocket and manages the WebSocket connections, and all you really need is the business logic for OCPP 201. You don't need Citrine's WebSocket server capabilities. That's pretty easy to do since it is modular. All that would need to happen is the OCPP messages would be put onto a message broker, and then Citrine could take care of the rest. So we've seen actually in conversations with prospective implementers of Citrine OS that it's pretty easy to take a 1.6 charging station management system and use Citrine to bootstrap that system to 201 compliance. from the other perspective, from the charging station side, 201 was actually made with an eye towards being able to support chargers that had been, their firmware had been based off of 1.6, and they're trying to get towards 201, but might not be able to do it all in one step. So some critical messages that are deprecated in 201 are still supported. So status notification, meter values, those two are sort of the core of the data flow for OCPP 1.6 charger. And although both of those messages are deprecated, they are still supported in 201, which can help ease a 1.6 charger into a 201 implementation. So the implementer of the protocol tried to design it with an eye towards making that step less painful.
Did you address this one, Donna? Are there any other PKI certificate authorities? You haven't got that one?
So I sort of answered that with the other question. Right now, Hubject is the only one that Citrino OS is compatible with out of the box. I haven't seen much evidence of non-Hubject PKI authorities being used in North America. But if we did, we would also seek to add those to Citrine. Frankly, the APIs for the different certificate authorities are fairly simple. So adding support for additional certificate authorities would not be much of a stretch. It could even be part of a custom scope if it's one that's not commonly used in the sphere and thus doesn't make sense to add to the open source.
Got it. Cool. And I think I'll take the last one, as I know Thon already spoke to most of it, but we're getting up on time, so we'll probably just close it out with this one unless anything else comes in. But how do you help OCPP 1.6 based platforms achieve OCPP 201 capabilities? Thought I basically already wrote through that one, but just to get back to the presentation, the Citrine OS as the open source version of the CSMS is OCPP 201 focused only. There's no 1.6 backwards compatibility in the OS. But one of the things that S44 does with our go-to-market for our clients is, as I mentioned earlier, when we are talking about what does the client need in their build and what features are important to them, we engage in custom 1.6 builds if the client does not already have one, and incorporate that into that custom CSMS build. And I think that's really it. The only other thing that I would add is I guess what Donna mentioned earlier is if there's an existing 1.6 ecosystem and there's the need to adopt a 201 implementation, then we would most likely use the open source or some version of the open source in a custom implementation to be able to achieve that organization to be able to be running both 1.6 and 201 chargers, depending on the situation. And you are more than welcome. I think we have my QR code up. Yep, you're more than welcome to scan the QR code, and that'll book a meeting directly with me via a Calendly link, or go on the S44 website and send in an inquiry, and this team would be more than happy to answer any additional follow-up questions that weren't surfaced in this webinar, or book a meeting to discuss any particular challenges that your team has and how we can help overcome them.
Also, if you're interested in contributing to the code base or being involved in some of the technical discussions around its future and its design, we have technical steering committee meetings on the first Thursday of every month. where we kind of go over the current state of development. We have an open mic, and we talk about the future of the project.
All right. Thank you, Donna. Thank you, Christian. Thank you, everyone, for attending. We appreciate the attendance and engagement. Oh, I think we have one more question coming, possibly from Michael. Oh, maybe not. It looks like that's a wrap. Thanks, everyone. Appreciate it. Looking forward to speaking with you all soon. And we'll be sending out a recording of the webinar automatically post the call. And you're welcome to follow us on YouTube, our website, or LinkedIn. Thank you all. Have a good Wednesday.
Thanks.
Bye.